1.7 notes day 1 is talking about absolute value equations. On day 2, we're going to explore inequalities, but for today, just equations. So the first thing I want to just note is what an absolute value really is. An absolute value is a number's distance from 0 on the number line. So if you notice, even -3, it is the distance of 3, right? Distance can't be negative, so absolute values in itself cannot be negative. Okay, so if something on the inside were negative, such as this -3, if you take the absolute value, end up with a +3. Okay, so anything on the inside, it can be negative, but when you take out the absolute values, it becomes a positive. Okay, so if we're looking at simplifying these equations here, well, expressions, I'm sorry. On the first one, you basically treat it like a parenthesis, but you don't ever want to really distribute into the parentheses. So start out by, looking at what's inside the absolute values and simplifying. So we have, and then we would have the absolute value of -7 here. So if we use the absolute value rules, we would pop out the negative and make it a positive, okay? Because the absolute value of -7 is 7. And then we have 6, which is 12. So we would have 14 plus 12, which ends up giving you 26. On the next one, we have the absolute value of 12 in this first chunk, and that is a positive 12. Then we have the absolute value of 54, which just stays 54. And then this gives me -12, and the absolute value of -12 is a positive 12. But it still is a subtraction sign in between these, so that's why there's still a minus. 12 divided by 6 is 2. 54 divided by 9 is 6. And remember, we need to go from left to right. So 2 minus 6 is -4, and -4 minus 12 is -6. So let's start talking about what we do when it is an absolute value equation. So essentially what we want to do is we want to get the absolute value by itself. Okay, so that'll be step number 1. Get the absolute value by itself. Okay. At the bottom, I just want to kind of star this. Do not distribute into an absolute value equation. All right, so if you're gonna look at this first absolute value equation, it is already by itself, right? The absolute value is completely on its own. So once that happens, as long as it equals a positive number, you can split it into 2 equations. Because I know that x can be the positive 300 unit, or it could be -3, right? Because it could be negative, and then when you pop it out, it becomes positive. Okay, so what's inside can be negative or positive. Okay, so essentially our answers are both 3 and -3 here. And if you think about it, that's because -3 and +3 are both 3 away from 0, right? So after you get the absolute value by itself, your next step is to split into 2 equations. So it would equal the positive, and then it would equal the negative. Okay, and that is assuming that it originally starts with a positive. Okay, it has to equal a positive before you split it. Okay, so on the next one, the absolute value is not by itself first. So what we're going to do is we're going to subtract over. After we do that, we get 5 equals the absolute value of x. So absolute value is by itself, it equals a positive, so we can split it into 2 equations. So x would equal 5 and x would equal -5. So as we keep going, it's just going to be a little bit harder. They'll have more steps in between it, like before we split it, or more steps after you split the equation. So we're just getting a little more advanced here. Okay, so this is all by itself and it equals a positive. So that means that we can split it into two equations. So we get 2x minus 3 equals 1, and 2x minus 3 equals negative 1. Notice how this didn't change at all, right? The actual 2x minus 3 doesn't change. It's what it's equal to changes. It's the positive and the negative. So on both of these, we're going to add 3 and then divide by 2. So on the left, when we add 3, we get 4. Divide by 2, and we get. On the right, when we add 3, we get 2. Divide by 2, and we get 1. So that means x equals 2 and 1. In letter C, there are a few things that need to happen first. Absolute value is not by itself, so we're going to need to subtract 8 over first. So we have 3 times the absolute value of x plus 6 equals negative 3. Now if you notice, there's a 3 on the outside, and most of us are going to want to distribute, but remember that's one of the big rules. You do not distribute it in. So what we're going to do instead is we're going to divide by 3. And if we notice, x plus 6, the absolute value of x plus 6 equals negative 1. In this case, if you split it up into two equations, it might look a little confusing to you because it's already a negative, right? Remember, when the absolute value is totally by itself, it can't be a negative, okay? So that means that my answer is no solution. For letter D, many of you probably thought, oh, well, it equals a negative, so it's no solution, which would be the case if the absolute value was all by itself, but it's not. We have this 2 out in front, and we would get rid of it by dividing by it. And because it is also negative, it changes that to a positive 2. So now because absolute value is by itself and it equals a positive, we can split it up. So we get x plus 5 equals 2, and x plus 5 equals negative 2. On both equations, we would subtract 5. So x equals negative 3. And in the other one, when we subtract 5, we get x equals negative 7. Letter E, this one is always one that tricks people. Again, notice that it equals a negative right now, but that might not be the case once we get the absolute value by itself. We do not just subtract 2 minus 3. Think about this, and I've done this before in here. If you had something like 2 minus 3y equals negative 10, not a single one of you would say, yeah, let's add these two numbers. Okay, we know that it's not the case there. That's the same rule that applies for this type of problem. Okay, we actually don't do that. All right, instead, we would do what we do in the pink. We would subtract 2 to the other side. We get negative 3, absolute value of x minus 2 equals negative 12. Then we would divide by negative 3, again, not distributing it in. We get x minus 2 equals a positive 4. The absolute value is by itself, it equals a positive. So we split it up, x minus 2 equals 4, and x minus 2 equals negative 4. On both of these, all we would do is add 2. So x equals 6. Over here, x would equal negative. So x equals negative 2 and 6. Forgot to do it on this last one. Negative 3 and negative 7. I encourage you to try these two on your own before you watch me do it. So go ahead and pause the video and do that before I start explaining. On letter F, all we have to do is subtract 3 to solve for, or to get the absolute value by itself. And when we do that, we get an absolute value that equals a negative number. And whenever that happens, our answer is no solution. Letter F part 2 is supposed to be G. I don't know why it's not G. My bad on that one. Letter G now. You would, again, similar to the one right above it, you do not do 5 minus 2, you subtract 5 to the other side. And we get negative 2, absolute value of 3 minus 2r equals negative 28. And then we would divide by negative 2, distribute here. So we get 3 minus 2r equals a positive 14. Okay, so now it equals a positive and it's by itself. So we get 3 minus 2r equals 14, and 3 minus 2r equals negative 14. On both of these, we would subtract 3 and then divide by negative 2. So in the first one, we get 11. So r equals negative 11 halves. On the second one, when we subtract 3 and then divide by negative 2, we would get negative 17 divided by negative 2, which gives you a positive 17 halves.